Hello, I'm going to talk about quantum machine learning concepts and applications. This document was created in collaboration with Javier, which is my colleague from University of Mumbai, and Javier Orduz from Mexico. Okay, in this slide you can see the contents, but let me go to the motivation. Motivation is in fact around physics. In particular, we want to use quantum computing and also machine learning algorithms around high energy physics. In this slide, you can see the machine learning concept, but in fact, we want to use machine learning to analyze the big information, also big data coming from process as collisions of particles. In this slide, you can see the types of learning. At least we have two: supervised learning and also unsupervised learning. In this part, you can see the quantum computing. Quantum computing was proposed by Feynman, and in this paper, you can see different questions that Feynman asked himself. For example, he wants to know what kind of computer are we going to use to simulate physics? Okay, after David Deutsch proposed the short-story principle to simulate some process considering the idea that Feynman proposed. But in fact, now we have quantum information. Quantum information has three areas at least. First one is quantum computing, and also quantum information theory, and after we have quantum cryptography. In this slide, you can see some quantum computing algorithms, and here you can see some algorithms that we can use in high energy physics. For example, first one, we can use the quantum supervector machine in order to classify some information. After, you can see the quantum Boltzmann machine, which is a type of recurrent neural network based on Hopfield network, for example. In this slide, you can see the K-means, which is a kind of algorithm coming from classical K-means algorithm. The other one is Q-generative adversarial network, which is a very interesting network to do analyze in a supervised learning and also unsupervised data. In this slide, you can see some approach for quantum machine learning. In particular, this chart can be found in the Peter Wittek book. Perspectives is about, in a theoretical view, we want to use some tools to do analyzing high energy physics, considering some tools, for example, SARA, Pennaline, DWeb, Qiskit, and PyHep. For example, to do classification or also to find some patterns or analyze data. Okay, finally, let me go to the conclusions. Here you can see two. First one, I mentioned some tools and concepts around the high energy physics to do analyze with the big data coming from different experiments around the world, for example, CERN and also Snow Labs and other labs around the world. And second one is I show some applications and fields to do research, for example, to classify some kind of particles or process in high energy. In high energy physics, there are more applications in other areas as economy, finance, biology, chemistry, and also in health. So thank you and see you.